Hi. So today we'll look at a full stack web application which uses machine learning, or we can say that full stack data science project which helps to calculate the body fat. So basically this project tends to estimate the percentage of body fat in a human's body based on several parameters like weight, size of the hip, chest size, and many more parameters. So quickly let's go through the workflow how this is. So as usual in all the data science projects, we first load the data into the pandas data frame, and then we perform exploratory data analysis. After exploratory data analysis, we get all the selected features, and the data is almost clean. Now it is ready for now it is ready for model building. So we select the perfect machine learning algorithm by tuning the hyperparameters of it, and then once everything is settled, we save the model weights in a pickle file, and then we integrate that pickle file by unpickling it into the UI. The UI we can make using Flask or Streamlit or any other full stack application if you want, but it should use Python. You can use Flask, Django, or Streamlit, anything. Then we will be deploying our machine learning model or the full stack data science project on Microsoft Azure cloud. So this time we'll be deploying it on Microsoft Azure. So let's look at the demo of it. So if it's deployed on Azure, then you will see this kind, like it's at the end it will be written as Azure websites.net. So this is the demo. So I have given some kind of information regarding body fat estimation, how this is to be calculated and all. Here's the context, and then here's the kind of information about the data set which we are using, and then this is the content which is there, and then there are more details onto it. There is some score, there is some kind of metric on which this body fat estimation is calculated. It is known as series metric, because Siri was the person who gave this formula for calculating or estimating the body fat. Then there is all kind of statistics, and then there is kind of source which you can go over here, and you can just browse through it, and here are the references from which the entire data set has been made. So let's go on and checking the body fat estimation. So I'll just give some density of underweighing weight, abdomen circumference in centimeters, chest circumference in centimeters, weight in lbs is nothing but pounds, hip in circumference. If I just hit enter, if I just hit predict, I get the percentage of body fat is something around 9.96% in the body based on those parameters. Now information regarding the body fat estimation, again the same information has been displayed over here as well. Okay, so this is how we are gonna make this simple project, but the deployment is a little bit complicated in this, because we are deploying it on Microsoft Azure cloud. It's not on Heroku or anything. Microsoft Azure is little bit slow, and it takes a lot of effort for deploying it, so deployment phase is little bit tricky. So the deployment and the exploratory data analysis phase in this project is little bit tricky. Rest everything's are normal as we go on for a full stack data science project. So in the next video we'll carry on with the exploratory data analysis part. Hi. So in the last video we saw the working of the body fat estimator, and we saw that there was some kind of information which was displayed here regarding the dataset and what all things are needed to be done, and then we saw that how this machine learning model is calculating the body fat, as how it is estimating the body fat in a person, and then there was this information again. So in the last video I said that we will be starting with the exploratory data analysis. So the first thing is we would require all the preliminary libraries, that is pandas for panel data, numpy for numerical operations, seaborn and matplotlib for data visualization. Just shift enter this, so this gets executed. And then over here we will be requiring the bodyfat.csv, which is present over here, bodyfat.csv. The link of the dataset is been the dataset will be provided in the files folder, so please do download it, and then just simply hit shift enter. You'll get so many. The good thing about this dataset is there is no categorical feature here. Everything is numeric, and over here we are about to predict for body fat. Body fat is our main goal, and all the other features are the dependent features. Our independent feature is body fat, and all features are dependent. So let's look at the info. There are no null values inside this data frame, so it's clean, and there are like 252 records of the there are 252 rows in this data frame. It's a small data frame with no categorical variables, no categorical values, and no null values, so it's going to be pretty straightforward. So first, whenever you are having this kind of numerical values, what you need to do is you just need to check the distribution of it. Just check the distribution of every single column or every single feature. If they are following some kind of Gaussian distribution, then definitely linear models will outrace it. So that's the thing which we are doing. So I defined a function named as distplots. Distplot is nothing but distplot will show us the KDE plot and also the histogram in it. KDE plot plus histogram. KDE is nothing but kernel density estimation plot, which is nothing but a which will plot the distribution of the particular column. Okay, this function is taking in the parameter as column. This column is nothing but the feature which we will be passing from this for loop. So this is the figure plt.figure. I want a figure of size 12,5, so it should be of size 12,5. Okay, and then sn.distplot. This distplot function is present in the Seaborn data visualization library, and which where we will pass this this parameter which we want to plot or which we want to see. Basically we want to see the distribution of df of body fat. Okay, df of body fat, we want to see the distribution. Color is equals to magenta, hist is equals to false, and label is equals to body fat. So over here I am plotting two distributions here. So as I said earlier, that body fat is the one which we will be looking for. Like body fat is what we will be predicting, and so that is why it is our dependent feature, and all other features except body fat are independent features. So now I will try to see how those independent features are relating with the dependent feature. That is how age is making a relational impact on body fat, how weight is making a relational impact on body fat, based on distribution of them. So that is why first I am plotting the distplot. First I am plotting the KD or the distplot of body fat, where I am setting the color to be magenta. Hist is equals to false means in this distplot you will be having two kind of features. You will be having KDE and as well as hist. So if you just hit shift tab over here, so you will get the function definition over here. So as you can see, A is nothing but our data frame or whatever we want to plot. Bins is in regarding to the histogram if we want to plot. KDE is the one which we are looking for. We are not looking for histogram here, and all other things you can just see and you can tweak and play it with that. There is some kind of examples also which will be given in the bottom. You can go through the description of this. So in this I will not be using histogram, so that is why I am using hist is equals to false. By default KDE is true, so KDE is true, and label for this particular plot is body fat, because I am plotting the body fat first. Now this is the dependent feature, that is body fat. Now our independent feature is nothing but the call which we are passing from the for loop to this function. So df of call, color is equals to red. In order to distinguish between the body fat and this the dependent feature and independent feature, the color must be different. So that is why here magenta, here it's red. Similarly, as I said that I'm not interested in plotting the histograms, I'm interested in plotting the KDE plot. So label is equals to call. This call is nothing but a string which will be passed. Okay, and then plt.legend means it will showcase the labels onto the charts, and then plt.show means it will showcase it will plot the figure. So this is all about this distplot function. Then what I'm saying is columns is equals to list of df.columns. By default, if you just type in df.columns, what will happen is it will give you the index. Okay, it will not give the if you just type in df.columns over here, it will not give a list. It will just directly give some index kind of thing. So this will not work. This is not iterable thing. So so what we need to do is I need to convert this index into a list. So that is why I'm using list of df.columns. And for I in columns, column is nothing but density, body fat, age, weight, and all. So I'm giving a print statement here. Distribution plot for, I'm using basically an F string. Distribution plot for a particular column, that is density feature is shown below. Like this over here, you can see density feature is shown below, and then I'm passing, and then I'm calling this function where I'm passing the I is nothing but iterable iterable, which is iterating through this calls list. So first time density will be passed, then body fat will be passed, then age will be passed, then weight will be passed, and then print. I'm just printing this so that there is kind of understanding between the plots. So when I execute this, you can see there's some kind of warning, but that's not an issue. So over here we can see that the density plot and all, this plot is basically for the body. Let me just execute it again. Okay, so this kind of issue, that's not an issue at all. It's just an update kind of thing. So we can see that the red one is nothing but the density, and purple one is not, and the magenta one is nothing but the body fat. So there is no kind of relation between the body fat and density. It's totally rubbish here. If we see body fat and body fat, obviously the same feature will have some kind of relationships, so you can ignore this as well. Now you can see here the body fat is Gaussian, and the age is also a kind of squarely Gaussian. And then you can see weight and body fat, they are almost getting not too close. Weight is somewhere around here and body fat is somewhere around here. Similarly, body fat and height you can see. Similarly, body fat and neck, body fat and chest, this can be a good feature because this is also Gaussian and this is also Gaussian. Abdomen and body fat go in side by side because they too also are similar kind of distributions. Hip can also be considered because both of them are slightly, you can see an uptime on the hip, but that's fine. Body fat and thigh, body fat is little bit wider, whereas thigh is little bit thinner or skimmer, and knee is to nowhere into consideration and all. And ankle is of no use only because the distribution, from the distribution only we can say that ankle is nowhere gonna support body fat. Biceps nowhere gonna support, forearm nowhere gonna support, wrist nowhere gonna support. So you see, just based on this distribution plots, we can eliminate few of the features orally we can eliminate few of the features. That powerful this distribution plot is. So whenever you are having numerical features, do make sure that you after cleaning all the null values and everything, do make sure that you plot the distribution plot and check, because half of the features will get eliminated with the distribution plot only. And you will see how this magic happens. With just 5 columns I'm getting a wonderful result at the end. Okay, so that is all to it. Just explore about the distribution plot of Seaborn library. It's a very important tool. Thank you. Hi. So in the last video we saw how the dist plot is very important in case of numerical features, and how we can quickly eliminate few of the features by just looking at the distribution of them. So by just looking at the distribution of them, we can eliminate few of the features. A similar kind of technique which we will be applying now is known as the distribution analysis now. So which kind of whether the particular column is following a Gaussian distribution, a left skewed distribution, or a right skewed distribution, like that. So for that I'm going to use the SciPy library, that is from scipy.stats, import stats, and then I'm going to define this function which is draw plots, which takes in the parameters as data frame and column. So let me just import this library, and then draw plots will take up this data frame and column function. So first I'm gonna make my figure, that is plt.figure as this, and then I'm gonna make subplot 1, 3, 1. What this means is 1 is basically the row and 3 is basically the columns. So 1 row 3 columns, and from that 1 row 3 column I'm selecting the first column for plotting the histogram. As you can see here, this is 1 row, and in 1 row this is column number 1, column number 2, and column number 3. So I want to plot column in column number 1, I want to plot histogram, so that is why I kept column number 1 over here. Okay, so plt.hist, in matplotlib there is the hist function which is used to plot the histogram. So I'm just passing df of call. So this df of call is nothing but a series object which will get passed, and then I want that color of the histogram to be magenta. So this plot will be plotted at the first column. Now in the second column, plt.subplot 1, 3, 2. So this basically indicates that first row has 3 columns, and of that 3 columns I'm selecting the second column now. So this is the second column. So in the second column I want to plot the probability plot. Now what is this prob plot is basically is this prob plot is nothing but it's a kind of a it shows a kind of a Gaussian relationship between variables. So what do I mean by that? Let me just explain it quickly. Okay, so what do I mean by that is basically yes, so in Gaussian for let's say that over here we are having a Gaussian distribution curve like this. Okay, we are having a Gaussian distribution curve and we want to plot a disk plot of the, we want to plot a pk probability plot of it. So what happens is simultaneously I'll take this point over here. This ranges from like minus z to z, if I'm not wrong, minus sigma to sigma basically, and then here it is 0. So based on the formula that z is equals to x minus z score is equals to x minus mean, that is x minus mu by sigma, where sigma is the standard deviation. Based on this z score, basically we will plot the distribution over here. So for example, this point is there, this point we will plug it into this, and then we'll get a point over here. Okay, this point is there, this point we will plug it into this formula and we'll plot it over here. So basically over here we will be having a red line like this, which says that this will pass from origin, that is 0. So in standard normal distribution, we know that the mean of the thing is 0 only, right? As you can see from here also, it will just pass from this. This basically means the standard normal distribution starts from -3 to 3 over here. So that basically says that what that basically indicates is yeah, this is -3 to 3. That basically indicates that this is a standard normal distribution where mean is 0. So whenever mean is 0, so this formula basically becomes x by standard deviation. Okay, x by standard deviation. So simply you just plug in this values over here. These values are over here, these values are over here. Just plug these values into this formula and plot them over here. Okay, so for example, if I plot them over here like this, let me just erase and redraw and show it to you once again. So let me say that, okay, so let me say one thing. Yeah, so over here, for example, the scale goes from -3 to 3, right? So -3, -2, -1, 0, 1 and 2 and 3, right? So over here, suppose that this point is there over here, this point, I'm finding this value, I'm plugging that value over here, I got a result over here, somewhere over here I got a result. So this is nothing but my y value and this is nothing but my x value. Okay, so now this point I calculated the y and x value, I plug it into this, I got the result over here somewhere. Now similarly I will be doing for every data point which is a part of that centralized distribution, and I observe that I'm getting some kind of data points in this fashion over here. This is kind of scattered. So now this kind of thing I'm getting. Okay, so if I draw a particular line over here like this, so I see that this kind of distribution is not centrally distributed, because it's kind of varying around the mean. So basically, if it's exactly a centralized distribution, what will happen is you will be getting the blue dots on the line only. So whenever you get blue dots on the line or little bit they are around the variation of it, that means they are perfectly centralized. So as you can see, for example, this one like this, exactly this. So you can see that this distribution is a perfect bell curve, and based on this perfect distribution only this line is getting plot. So this is the probability plot, which is also very important in order to understand how the distribution of the data is, whether there are few outliers or not. We can see that there is one outlier which is over here and it's visible over here also. Okay, so this is all about this prob plot. And then box plot, we use box plot for finding out whether there are outliers or not. So in box plot, basically it will help us to know whether there are outliers in our distribution or not. So these are the three combinations of plots which I'm using in the subplot. So and plt.show will plot all these three columns. So this is all about this draw plots function, and I'm gonna find the list of so for every column I'll just plot this. So distribution plot for feature calls of I, that is nothing but first feature is density. So distribution plot of density is, so density will be passed over here, df and density will be passed over here, and all the three plots will be plot for the column named density. So we can see the distribution, we can see the histogram for this like this. Simultaneously we for all plots we can see the functioning. So for all plots we can see the functioning, and we can see that every value is almost like every function or every feature is a Gaussian distributed, either a left skewed, right skewed, or centrally skewed. So this is this is like a bonus thing to us, because we rarely get Gaussian distributed things. So once we are getting our normally distributed values, now there is no need of any kind of pre-processing only, because it's almost done. If everything is under normal distribution, there will definitely be good results out of it. So there is no kind of more kind of extraction and everything which is required from this. But what we need to do is we need to eliminate few of the features. So eliminating few of the features is a technique of feature selection. So we'll be looking at feature selection in the next video. Before that, we will be also looking at the outliers, if there are any outliers. So over here we can see that I kept an upper limit and lower limit. So this is a standard normal distribution formula where we, like this -3 is there, no? If we are having values less than -3, that means that is an outlier for us. If we are having values greater than 3, that means that is an outlier for us. So basically what this entire thing is saying is this. Okay, just a second, I'll just erase it. Yeah, over here if I just look at the formula over here, what this is saying is yes, so this kind of formula is being used here. So yes, so basically upper limit dot append df of I dot mean plus df of I dot std times 4. So as I said that in Gaussian distribution we have the limits like from -3, -2, -1, and this is 0. Here we have 1, 2, and 3, and the bell curve will be like this, and this is a perfect Gaussian. Okay, so if I'm having values less than -3, that means it's an outlier for the centrally distributed curve. If I'm having values greater than 3, that means that is the outlier for this curve. So that is what is written over here. So lower limit must be lower limit must be within the range from -3 to 0, and upper limit must be within the range from 0 to 3. If it is beyond -3 and if it is above 3, that means that is considered to be as an outlier for this normal distribution. That is what this entire 2 lines of code is saying. Okay, so I'm calculating that, and then that is what it is written here. df calls of upper limit if there are values which are greater than the upper limit, and if there are values which are less than the lower limit. That means if there are values which are less than the upper limit, that is 3. If there are values which are greater than the upper limit, that is 3, and if there are values which are less than the lower limit, that is -3. If there are so kind of values, just ignore them. So that is nothing but our outliers. Okay, so if we just see, we do not get any kind of outliers here, so it's automatically handled. As I already said that if the distribution is completely or purely Gaussian, there is no chance of getting outliers. Even these 2 outliers are automatically skipped when we do model processing and everything. So there's nothing to worry about outliers. We get outliers when there is some kind of skewness in the distribution. So that's not an issue to be worried in this case. So that's all for outliers. We'll be looking at feature selection in the next video. Hi. So in the last video we saw at the distribution analysis and outlier checking. So we found that there are no outliers and the distribution was perfectly Gaussian, and we saw how the relations of Gaussian we saw how Gaussian distribution works, and how outliers can be checked using Gaussian distribution formulas. So now we will see at the feature selection, because as I already said in the last video that every feature is going to give contributions over here. So there may be some kind of correlation which will happen, and there may be some kind of not all features are mandatory, because we in the starting EDA video I said that there are few features based on whose distribution only we can say that these features are important or not. So let's have a look at feature selection techniques, few of the feature selection techniques. So basically, whenever we are doing some feature selection, there are few predefined algorithms like extra trees, mutual information gain, and many other techniques are there. We can use lasso regression and many other techniques, but profoundly ensemble methods give us good results. So I'll be using with extra trees regressor. So over here, first step, what you need to do is you do not need to do some kind of updates directly on your data frames. So please maintain a copy of the data frame. So that's why I'm doing data is equals to df.copy. And then take out your test data, take out the independent feature, and separate the independent and dependent features into test and train set. Just execute it, and then from sklearn.ensemble import extra trees regressor. Er is equals to extra trees regressor. Just initiate the object, just fit the object. It will take some time, and we get the object over here. Then what we need to do is, there is some kind of feature which is known as feature importances. So if we just type and print it over here, if we just type it, we get the feature importance of everything. So basically, this feature importance, what does this say is, this basically means that the feature number 1, it is giving 73.4% importance to the body fat. This feature, that is 0.0016, is just giving almost giving 0.016% importance to this body fat. So there are some kind of features which are giving good importance, which are giving some good results, and there are few features which are not giving. So basically, in this kind, it is not easy to visualize. It is not easy to interpret. So what we'll do is, we'll kind of plot some graph. So what we'll do is, we'll see pd.series er.feature importances, and index is train.columns. This is train.columns over here, and then what we are saying is plot the bar graph of the largest 5 features. That means the 5 features which are giving more kind of relation with it. So if I just do it, we see that weight, hip, chest, abdomen, and density, these 5 features are giving some good results as compared to other features. So this is one technique of feature selection. We can say that we can use feature, hip, chest, abdomen, and density. Density feature too, you surely must use. And another feature selection technique is nothing but mutual information gain. So from sklearn.feature selection, I'll import mutual information gain. So in the same function, mr is equals to mutual info regression, train and test. I'll pass it, and then I'll execute it, and then plot data is equals to pd.series mr, index is equals to train.columns, and then same kind of things which I did over here, I'm gonna do it over here as well. Okay, so when I try execute it, I get this kind of result. So in this, what it is, here hip, chest, abdomen, and density were common. It is common over here as well as over here, but this mutual information gain is saying that thigh is giving good relation than weight. So weight was almost like not giving some kind of good insight over here, but over here, in using mutual information gain, thigh is giving some kind of information. So let's check whether there is some kind of correlation or not. So first we'll look at the data, then we'll look at the correlation map over here. So when we see the correlation over here, we see there are so many correlated features in this. When you get some kind of heat map like this, like varying colors over here, this indicates that there is a lot of correlation which is going to happen. So basically, in feature selection, there are 4 techniques which you primarily must do. First technique is, you use extra trees regressor for a regression problem statement. If it's a classification problem statement, you use extra trees classifier. Next step, you go for mutual information gain. If it's a regression problem, you import mutual info regression. If it's classification problem, you import mutual info classifier or classif. So if you type it over here, you'll get mutual info classif. You can type it that also. Okay, so you do these 2 steps, and the third step is go for correlation checking. So over here we observe that when you just do df.core and plot a heat map with anode is equals to true. Anode means annotations. In this box, the numbers will be written. That means anode. Okay, and cmap is equals to plus by, it's nothing but the color whatever you want to give to the to the heat map. So we find here there is a lot of correlation which is happening between many features. So there are we need to kind of remove the correlation. So for removing the correlation, I'm defining a function which is nothing but this def correlation, which will pass in the data frame and the threshold. So based on a particular threshold, I will say that if any two features is having a threshold of this correlation, then I will ignore one of them. Okay, so call color is equals to call core is equals to set. Basically set I'm using in order to remove duplicates. I could have used list also, but list it allows duplicates, set doesn't allow. So core mat is equals to df.core. So if you just simply do df.core over here, you'll get a correlation matrix. So basically I'm plotting that correlation matrix in a Seaborn library heat map. So this is basically a matrix only. So density will be 1, body fat will be 1, age will be 1, right? So how many features are there? That many features times that many rows. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 15 cross 15 matrix, that is 225 cells are there in this. So this matrix is df core mat is equals to df.core. So so for I in range, len of core mat, so I'm iterating through rows, and for every column in a row, here I have written a particular line. Based on this, it's easy to understand. For each cell, get the value of that cell by iloc of ij. If iloc means I locate, index locate. So inside that index, what you will locate? You will locate for value only, no? So it's basically, it conveys the meaning automatically. So where I is the row and j is the column, if that abs value is greater than the threshold, get the column name and then add it into the set. So what I said is, if any value is greater than that particular threshold, let's say that 0.8 is the threshold which I set. So if a particular column is having correlation greater than 0.8, that means I have to remove it, because it's kind of getting too much into because it's kind of affecting a lot into my analysis. Okay, so over here, that's what I've written. If absolute of cormat.iloc. So why I wrote abs is basically in correlation, we'll be having positive correlation, negative correlation, and zero correlation. So positive and negative correlation, in scale they will differ. The negative symbol, the sign you can take care with using absolute. Okay, it conveys the same meaning only. So a feature can be more positively correlated, more negatively correlated, less positively correlated, less negatively correlated. So based on those, the matter is only the scale. The sign is nothing. The sign is just saying whether it is positive or negative. The entire thing depends on the scale. The value of the correlation should be taken consideration. Yeah. So that's what. If abs of cormat.iloc of ij, if it's greater than threshold, then call name is equals to cormat.columns of I. So get the columns, get the name of the column, and then add it into the set. Okay, and then return the call core, that is nothing but this set. So let's call this function, and over here we see that we get 5 columns that are nothing but abdomen, chest, hip, knee and thigh. So we got the same thing over here, abdomen, knee. Over here we are getting knee. We are getting here knee. We are not getting density. Okay, we are not getting density, but in this we got density. We were not getting knee. So you can see that you can from this entire mutual information gain, extra trees, regressor and correlation, we got to know that chest, abdomen and hip, they must be there in our features. They must be our features. Okay, so I have written here some points from the above feature selection technique. Yeah. So now what I have to do is there is one more way how we can remove this correlation. We can use this what we say that variance inflation factor. So over here, this problem is the correlation problem can be handled with the respect to homoscedasticity and if there are so many features which are tightly correlated, that means we can remove them with the help of variance inflation factor. Variance inflation factor is nothing but it will say how much amount of variance is a particular feature or a dependent feature is impacting independent feature. That is nothing but the variance. So if it is so much of variance is there, that means that feature will highly be responsible in case of overfitting. If there is low variance, that means that feature is not at all important. The variance must be in between 75 to 80%. So if it's in that range, that means the feature is gonna contribute a lot to the independent feature. Okay, so we'll be looking at the variance inflation factor in the next video. Till then, do practice the code of this. Go through the I would suggest that please go through how to remove correlation from how to remove correlation and how to prevent homoscedasticity, and also look at for other feature selection techniques as well. Hi, so in the last video we calculated how correlation matrix helps us to find how many correlative features are there with each other, and we said that we will be using variance inflation factor to remove that correlation and homoscedasticity. Yeah, so from stats, so stats model is a library from where we can get this variance inflation factor. So what I'm doing is I'm calculating, by this I'm storing the data frame into temp. The entire data frame, the data frame I'm storing into temp, and then info is equals to pd.data frame. So info of VIF, that is variance inflation factor, is equals to variance inflation factor of temp.values comma I for I in range temp.shape of 1. So temp.shape of 1 is nothing but what? Temp.shape of 1, if you just try to calculate it, so basically what happens is when you just execute this code, okay, when you execute this code over here and just say temp, you will find the data frame here. Okay, this data frame you will get. So if you just do temp.shape, you will get the shape of the data frame. So temp.shape of 1 is nothing but 15. Temp.shape of 1 is nothing but 15. So there are 15 columns, right? Yeah. So what I'm doing, temp.values, if you do temp.values over it, what you'll get, you just see. If you do temp.values, if you do, you'll get this array. So if you just visualize temp and temp.values, you'll understand the things more clear. Yeah, so you can see this list, this index 0 is over here, this index 1 is over here. So basically this data frame is getting converted to a numpy array, nothing more than that. So what I'm finding is variance inflation factor will take in the column, the index number and the values. It will take in consideration these values. The most important part is it will take in consideration this array basically. Okay, and then it will calculate the variance inflation. So once I got that variance inflation, if I execute it, okay, I didn't import it. Okay, so if you want to import this module, stats module is not there. So basically I did it using Anaconda, but now I'm using a local machine. So basically if you get these kind of errors, don't get tensed. Just do pip install stats model, whatever they are asking that no module fund, just hit this and just hit it. It will take some time, it will load the package, and once it is there, we are all set for it. Okay, it will take some time to download that stats model library. So basically what will happen is because of this variance inflation factor, we will get the importance of the features indirectly based on the variance of that. Okay, so this has got collected, and then we will import this, and then we will try to execute this code. This should work. Yeah, we see that density is giving a lot of variance or lot of importance. Over here also we saw that in this both cases density was outreaching it, right? So this means that density column is giving a lot of information, or maybe it is giving too much information to the model. That means too much information so that it can overfit it. So that is giving a too much of information over here. So if we try to try to get the calls 1 and calls 2 list, so we get results over here. So we see that density, abdomen, chest, hip, weight, and density abdomen. So we'll go with width and hip method, as hip and thigh are very much related. So we'll select calls one feature. So whatever I have written in this line, it's very self-explanatory. So I'm gonna take the calls one, which is these. So basically, if this doesn't give any kind of good relation, I'll exclude this. I'll take this. Simple, right? So to train is equals to this. I'll train it. So my model is this. So my training data is this much. So from 15 columns, I reduced it to some 5 columns. So basically what the idea is, there are two kind of, as I saw that there are two kind of different features, 5 features which are giving me the rating. So what I'll do is, I'll first try with first 5 features, that is in this calls one. In this calls one, I'll first try with these features. If these features are giving good result, I'll choose that features only. If these features are not giving good result, I'll definitely choose these features. Simple. So in the next video, we'll look at the model building phase. Hi. So in the last video, I said that we have two kind of columns. We have two kind of features. So we are first going with this first column feature. So now we'll be building our model. So for that, we'll import our libraries. That is from sklearn, import train test split, randomized search, metrics, import tree, decision tree regressor, random forest regressor, support vector regressor, linear regression, lasso regression, and ridge regression. All these modules will be importing from sklearn, and then we will be splitting our training data into train and test. And then first we'll go with directly ensemble techniques, so that it is very quick and fast, because we know that decision tree ensemble methods give us good results. So we'll plot the tree, we'll see and look at how long the tree will go. So regressor object is equals to decision tree regressor. I'll fit that object, and then plt.figure, I'm keeping the size that the tree must be of 15,7 size, and then tree.plot tree reg filled is equals to true. Filled is equals to true means it will fill in all the Gini impurity or whatever score it has calculated in the making the nodes. So it will take less time because the data set is relatively less. Now it will showcase the paths and showcase the tree over here for us. So once the tree is built, we can get to know, yes, the tree is built. So we see that the tree is little bit large over here. So we'll try to prune this tree. So for pruning the tree, we have some features known as cost complexity pruning path. So we'll be using this path is equals to regressor.cost complexity pruning path, and we will calculate the CCP alpha. Once that is done, what we will do is, if you just look at the CCP alpha, we'll be passing CCP alpha as an parameter to this. If you are having some kind of doubts, then directly just hit CCP alpha over here. You will find all these results directly. So first time you will send this, then you will send this, then you will send this, like that. Okay. So for I in range len of CCP alpha. So yeah. So if you calculate the len of CCP alpha, it should be some 201. I think it should be 201 mostly, because there are 157. Okay. So I think so 157 training sets are there. Yeah. So if you find the len of CCP alpha, you'll get it, and then for every CCP alpha you pass it, and then decision tree regressor object you fit it, and then you append into alpha list. So this alpha list will contain all decision tree regressor objects. If you just look at alpha list, I'll slice it so that it's simple to look, to understand and feel. So we see that there are decision tree regressor with CCP alpha objects. Calculate the train score and test score, and then plot this. Once we do this, we'll kind of notice some patterns. So the pattern which is falling from there, we'll be considering it. So we'll be considering like 0.2 over here. So I'll be considering CCP alpha value to be 1, because after that value, I see that there is a sudden fall of it. So CLF is equals to this, and over here normal approach, and over here random forest regressor approach. If I calculate this, how much I'll get? Yeah. So please remember that this is not a please do remember this, that this is a regression problem. So always you have to find the R2 score, not the accuracy score. So that is why I'm using the R2 score over here. So I get that random forest is getting some 92% accuracy, 92% R2 score, whereas decision tree is getting some 90% R2. Random forest hyperparameter tuning now. So I'll be passing the random forest, D tree, SVM, all the models. So if you want to get all these parameters, basically you just go to here and just press shift tab and then enlarge with this widget. So you will be finding all kind of parameters which you can use from here. Okay, you can read this and you can see some kind of examples also here they have given. It will give you some kind of results automatically. Okay, so this is all about the parameters dictionary, which is a dictionary inside a dictionary. So I'll execute this, then I'll apply randomized search CV, which is a hyperparameter tuning technique, where I'll pass the MP of model, where I'll pass this model that decision tree random forest regressor has been passed. And then distributions, parameter distributions is nothing but these all params. This params dict is nothing but the parameter distributions, and then CV is nothing but the cross validation. N jobs is equals to -1 means it will make all the cores of my laptop work, and then N iter is equals to 10, number of iterations. So this will run like 10 into 5 times, that is 50 times. And how many items are there? 1, 2 and 3. So 3 into 50, 150 times this entire thing will execute. So basically 5 into 10 is nothing but 50. So this randomized search CV alone will execute 50 times. And how many items are there in this? We have one random forest object, we have decision tree object, and we have support vector object. So there are 3 objects. So 3 into 50 is 150. So this entire thing will run 150 times. And the metric for every iteration is nothing but negative mean squared error. If it was classification, then this would have been accuracy. If this is a regression, then I'll say negative mean squared error. Then clf.fit xtrain and ytrain, then I'm basically I'll calculate the score. So the CLF, the classifier which gives me the best score, and the best estimator, I'll keep track of it. So I'll just execute it. It will take some time, and in the next video we'll look out at the scores. Till then, do practice the code. Thank you. Hi. So in the last video we completed the hyperparameter tuning thing, that this randomized search CV will run 10 into 5 50 times, and as there are 3 objects, it will run 50 into 3 150 times. So the entire loop will run for 150 iterations, and as it was taking some time, so I ended the video there. Now I have now this cell is completely executed. Now we'll see the data frame. I see that random forest is giving good score, -4.7, -4.63, and support vector machines is not giving good score. Random forest and decision trees are giving good. So let me just select the first one, and if I just try to execute this, I get 87.04 some percentage. And then simply I will try to kind of predict. I will try to train the entire data set. So np.train, np.array to train. So to train is basically our training data set. Okay, so np.array is nothing but our this data set over here, that is to train data set. So this to train I will convert into numpy array, and I will pass this numpy array into this rf.predict thing. So that is what I'm going to do. And if I execute this, so where that, yes, if I try to execute it, it will take some time, because this is a little bit this is a little bit slow, and after that we'll get some kind of results over here. Yes, so we see that we if this was something like 12.3, the predicted result was something 12.6. If this was 25.3, this was something like 22.9. If this is 6.1, this was something like 8.2 and all. So we get that kind of results. So basically what I'll do is I'll try to I'll try to get kind of good scores here. So if I just try and execute this, so yes, I can see that there is kind of variation which is going around here. So predicted result is in red, and actual result is in magenta. So this kind of variation which is going around here. So basically what happened is when you normally try and train this without using some kind of estimators and everything, basically if you try over here, if we observe that over here, normal this random forest regressor only was giving good kind of result. So if I just copy that and if I just paste it, basically when what happens is in randomized search CV you don't get exact results every time. So yes, you don't get exact results every time. So you need to do grid search CV and so many things, because that takes a lot of time to compute. So if I just normally use this random forest, n estimators is equals to this CCP alpha is equals to 1, that is giving good result actually. So I will use this and I will again predict the values. So it's saying me a value error over here because decision tree excess 7 features. Yeah, exactly. So now my two train feature, now my two train got changed now, because two train over here is having 7 features, right? So if I just look at two train here, so it is having 7 features, that is an actual result and predicted result. So what I will do is I'll remove them. Two train is equals to two train dot drop, two train dot drop actual result and predicted result, and I'm dropping the column, so axis I'll keep it as 1. Now I will look at two train. So yes, those columns are dropped. Now my two train is visible clearly. Now I will again execute this, so there will be no error now, because I have converted this two train into an numpy array, and then that numpy array I'm passing as a list over here, so to our random forest object, which is classifying things. So it will be ready in some time, and let's hope that it gives a good kind of result after all. Yeah, so over here we see that this was fairly good enough as compared to the last one. If this is 12.3, this is almost predicting right. If it's 6.1, this is not that great. 25.3, 23.7, 10.4, 9.5, almost similar. 29 point, yeah, so I think so this is giving good kind of result. If I just look at the plot, yes, so it's far better than the last one. So yes, so it's far better than the last one, and like this only we will try and kind of you try and tweak out some kind of parameters and check with other machine learning algorithms also. This is kind of okay-ish to me, because it's not too bad, not too low, as dataset was also less and everything, so it's kind of okay-ish to me. So what I'll be doing is I'll be saving the model with name body model fact model dot 1 pkl. If I'll save this, and basically I'm importing pickle file, and then opening this. If this is not present, this will be made, and then once this file is made, inside that file I'm writing all my random forest weights, and then I'll dump that, and then I'll close it. So basically I'll get my pickle body fat file 1 body fat model 1.pkl over here. So this was all about hyperparameter tuning and model testing, and in the next video we'll see how we can integrate this with the UI. Thank you. Hi, so in the last video we pickled our random forest object, and then we said that we'll be integrating it with the UI. So in the UI, what we have to do is we'll be using the Flask framework. So what I'll be doing is the first thing, let's look at the directory structure in this. So basically in Flask framework, what we have to do is we have to maintain our templates in a separate folder named as templates. So this must be very carefully done. You cannot just keep templates over here like index.html on this. A separate folder should be named with the name of templates. Only then the Flask framework will work. Okay, so templates must be created, and then the app.py is the main functioning file. So over here what we need to do is it's simple. So if you are having some kind of doubts here, so what you can do is you can just say Flask starter template, go to Flask starter template, just copy this minimal code, just copy this code and paste it over here, and then after that remove the things which are not required. So from Flask we'll import request, and we'll import render template. This request is basically used to say which kind of request is this, either it's a get request or a post request. Then we will say render template over here, so render template is nothing but it is used to render the template on the screen. Okay, and then pickle is used basically to unpickle the pickle is used basically to load this body fat model which we trained. Okay, so file is equals to open body fat model dot pickle in read binary mode. Over here we saved the file in write binary. Now we will read the file in read binary mode, and then we will load the file. The object over here, that is rf, has been loaded, and then we'll close the file. Then app name, we have to give this app name. This will automatically come from this thing only, from the starter template only. App is equals to flask name. No need to change anything. Now we'll make some kind of routes over here. So basically what this route mean is, if you just look at this thing over here. So if I try and calculate the thing over here, so let me just showcase you so that it's easy. When I hit on predict, you see that the route automatically gets changed over here. Okay, so routing is basically used to it's used from going from one template to other template. Okay, so I'll just illustrate it with the help of an diagram so that it's more easy to understand, right? So over here what I mean by that routing is 2250. Yeah, so let's say that we are having some 7 pages over here. So one is our home page which has a route which has slash route. Okay, we have some contact page which has slash contact, which has slash contact, and then we are having some blog page which is having a URL as slash blog, and then and then we are having let's say that we are having about page. So and we are having some other pages also. So this basically indicates that this is a home page. This is the home page of the website, and this is nothing but the contact page. This thing is there, no, this slash contact, this is a route basically to the contact page. So in a navigation bar, if we have some kind of navigation bar over here, we have some home and then we have contact. Okay, so if someone clicks on this contact, if someone clicks on this contact, so in the URL what will happen is, let's say that the URL was https some https : something, and here you are having dot some domain name. This is some name of your website, and then over here slash. When it's slash, that means it's a home page. When someone clicks on contact, here it will be contact slash contact. When someone clicks on about, this contact will get erased, this contact will go off, and when someone clicks on about, instead of contact, this contact goes, and then about comes, slash about. Okay, so that is all about the route. So in Flask framework, route is made with the help of a decorator. This is a decorator, that is @app.route. @app.route. App is nothing but our Flask app. So @app.route, and slash is nothing but the home page. So what kind of things it is taking is, it is taking two kind of methods, that is get method and post method. So these are nothing but the web architecture methods, or you may say that these are web programming standard methods or protocols. Get method, post method, del method. There are various kind of methods which you can look for this on the internet. We have get method, post method, patch method, delete method, delete, put, patch. There are so many kind of methods which are there, HTTP methods, which you can browse on and look for. So now we are defining a function under this route, so which is nothing but the predict function, which will predict our body fat estimator, which will predict estimator body fat by filling in the details. It will get predicted. So if the method is post method, now we have to look at the templates over here. So if you look at the home template over here, so in the home template, I have copied the home template from getbootstrap.com. So basically this this basically what I did is, in short, I'll say, just go to get bootstrap, just go to bootstrap.com, and then copy this template over here. I'll showcase how the template I made templates so easily and so fast. So let me make some dummy template over here so that it's easy to understand. Dummy.html if I make, and then enter, and over here if I just hit on this thing, Okay, so this is the dummy template. Now if I go click on go live server, so if you don't have live server in VS Code, you can just click on extensions and you can download the live server from here. Live server, you can download the live server. The first option itself is the live server, so you can go onto this and you can install over here. For me it is already installed, so it is showing me an install, so you can install there. So I'll be using this live server in order to showcase you how quickly you can make templates. Okay, so hit on this live server with Bootstrap and it is correct, it is working fine. So what I will do is I'll just remove this hello world from here. Okay, I'll just remove this hello world from here. Now I want my content to be visible, right? So in order to content to be visible, what I did is this thing is there, right? So this thing, actually this content I got it from internet and the source of this internet is Kaggle. So the dataset I downloaded from kaggle.com. So if I go on by looking at the kaggle.com, just a second, body fat estimator kaggle.com, right? I have it on my GitHub actually hosted, so I'll just you can download the dataset from here. Yeah, so basically this is the dataset. Okay, so body fat prediction. Now over here, this is the information which I need to replicate on my template. What I will do is, it's very simple. So what I'll do, just hit on inspect, just hit on this, and then just hover your mouse over here, you'll get this div over here, right? So just copy this div, edit with HTML, copy. I'll show it again. This is this part which I require. Just hit left click, edit as HTML, Control A, Control C. Just come at this page, just paste it and save it. Just paste it, save it, everything is fine. Now you just look at the live server over here. See, the context got rendered automatically. The context got rendered, is it not? So basically what I did is, here I kept everything in the alert. So what I will do, I'll just look for alerts over here. So just look for alert. So in this alert you will get some kind of alerts over here. Okay, so I actually copied it into this kind of alert. So just copy this alert over here. What you do is, you just undo this, you just make dot container, you just make a container class, div class is equals to container, so that everything is centered. Okay, so now you just hit in div. Yes, so basically it is Django HTML. If I do it HTML, it would be sorry, I did it in Haskell. If you do it HTML, it would be good. Yeah, so now paste the alert message here. So instead of, I don't want this tidy, this thing, I'll remove it. Now everything I wanted in this thing only, right? So I'll paste everything over here. So what was the thing? I have to copy it again. So Control A, Control C, and then paste it over here and then enter. That's it. So now this should work fine, I think. Let's see. Yeah, so exactly what I needed is, as you can see that over here also I'm having same kind of thing, over here also I'm having same kind of thing. Just you can rename this well done and context, and you can do some kind of additions and all that. That is self-explanatory and you can carry on with that. So in the next video we'll look at how to build the forms and how to integrate the post requests. Thank you. Hi, so in the last video we saw how we can make the template so quickly, how we made our template so quickly just by copying all the information from Kaggle, which was mentioned about the dataset. The dataset information was mentioned over here. We just copied it and then we just simply kept it in our dummy template, and we saw how quickly we made all the changes. So now we'll look at the form which was there. Okay, so in the home template, this template consists of the things. Now we have to make sure that we are getting the form over here, right? So the main heart of this is about the form. So over here, the form which we see over here, the form which we see over here, I'll just close all the tabs to write. The form which we see over here is the most important part which we want to make. So for that, what you need to do is, you can just go to get bootstrap again and click on forms and just get a dummy template over here, getbootstrap.com. You just go to getbootstrap.com, you go to forms, you select one kind of form whichever you feel like it's easy for you to understand. So I think so this is good. So you can copy it, and then in the dummy template you can paste it. You can do whatever so you want to do with that form, and you can do some kind of good things with this form. If you just click on the live server, here you will see that the form has come. So you can make some container over here. You can say that div.container. Okay, if you want to centralize the form, you can say .container. Basically container class will centralize everything. So yes, so container class will centralize everything. So if you just do this, the form will get centralized. If you want some kind of spaces also, if you want some kind of margin, you can say my4. That is, I want 4 units of margin from y-axis. So if you just see, yeah, you got some kind of margin over here as well. Okay, so these kind of things you can try and do yourself. So now the main thing is, in this form, action must be equals to this. So basically what happens is, when you hit on predict, when you hit on this predict over here, the action is what action is to be taken. The action is the data from here must go to the so if I just explain the architecture of this once again, it will be more clear. So just a minute, let's erase it. Yeah, so over here what is there is, suppose that this is a form over here. Okay, this is a form over here. Okay, you have some kind of features over here, and then you have a predict button over here, and okay, you have a predict button over here. Okay, and and the request type of this form is post. So what this post is, what postman actually does. Postman, what does a postman do? It transfers, or it kind of gets a message from XYZ person to you, right? Some XYZ person wants to give a message to you in form of writing or some kind of thing, some kind of letter. So postman will be a medium from X person to Y person. If X person wants to send Y person a message via post, so what he does, he just writes a post, he goes to the post office, he posts the post, the postman collects the post and then delivers it to the Y's address, right? Same kind of functionality with this Flask framework also. When this form is of kind of post, so whatever data has been collected in this form will be transferred, or will be shifted, or will be conveyed to the action wherever it is. So what is the action over here? Slash is the action. So over here, which route is taking slash? This route is taking slash. So basically what happens is, whenever you fill in the data in this and hit predict, so the data whichever is collected, data whichever you filled in this form will be stored in some JSON, and then this JSON, which is nothing but a dictionary, will get transformed, or will get posted to the service which is having a URL of slash. So which is having a URL of slash app.py. Right. So here, so if the request method is post, myDict is equals to request.form. Okay, so if you just try to print this myDict, you'll understand things more clearly. So just save this. If you try and run now, so over here I'm filling the form over here, I'm filling the details in the form. As soon as I hit predict, you see that the immutable dict, it got over here, right? What you can see that immutable dict, density is this, abdomen is this, chest is this, weight is this, hip is this. So whatever details I filled in this form, basically all those details got transferred to this route. So that is the meaning of that action. Form action is equals to this, to which route do you want to send the information, and the method of sending is nothing but post. So if request.method is post, you send you'll receive an immutable dictionary. So from that, what you need to do is, you need to this everything is in string, you can see that. Okay, you need to typecast the string into your requirements, whether integer or floats. So that's what I'm doing. Density is equals to float of my dict of density, my dict of abdomen, my dict of chest, my dict of weight, my dict of hip. So I'll get all my features over here. So once I get all my features, what I need to do, I need to send the input, right? How I will send the input? I need to send the input as a two-dimensional array. That is nothing but a numpy array. So I'm making a numpy array, and then I'm passing that information, that rf.predict input features, that is this input features it will take of 0. It will actually I'll get the result in form of multi-dimensional list as numpy array only I'll get. So I'll select the first I'll select the thing which is at the first index, and then I'll round it to 2 decimal places. Okay, so if I try to showcase it, it would make more sense, right? So let me try to showcase it. So I'll copy this. Actually you can also do Control D, that means it will duplicate it. So till now I'll just showcase something. Okay, I'll just print this so that it's easy. Print rf.predict input features of 0. So I'll not use this input, I'll not use this this thing, so that it makes more sense now. Okay, so if I try to rerun this, and over here if I try to fill in the form again, so what will happen is, everything I'm filling, this will go in the form of a immutable dict object. I'll get it, and you can see that the result I'm getting in the form of a list. So this list I want to I want the value inside that list, so that is why I'm using this. And then I want to round it to 2 decimal places, that is why I'm writing dot round 2. Okay, so that is all about the prediction thing. Now once I get the prediction, what I'm saying is the string I'm keeping, string is equals to percentage of body fat estimated is this, plus str of prediction plus %. This is the string which is there, and then I'm saying return render template show.html string is equals to string. So show.html is another template which I made using Bootstrap. So over here this is the alert. So over here you can see this this thing, this is one alert and this is one alert, which is nothing but information regarding the body fat estimation. So a percentage of body fat estimated is 9.96%, which is over here. So this is nothing but a Jinja syntax, which is coming from here. Okay, from here the data is coming, that means from the route the data is going to, that means I basically want to transfer the data from this route, that is this /route, to show.html template. So there I want to display the result whichever the route has shown. So over here I'm using this Jinja syntax. So this Jinja framework, you can also, this Jinja syntax and all, you can just go through Google and just look. It is very useful. It is almost used in Flask and Django both. So Jinja palettes projector, Jinja template designer. So you can see that you can not only you can use this, you can use for loops, you can use if conditionals, you can use so many kind of things. It's not just basically used to just display the information, say if true, yeah, and if and all. So if you already worked with Java, then this is kind of like JSP, Java server pages. Similar to that only in Python, this is in Flask, this is known as Jinja. Okay, so I'm displaying the information in this alert. So now in order to showcase more information, what I did is so in order to showcase more information, I just copied the dummy template and I just showcase that information over here. That's it, nothing more than that. So I just kept a go back method over here, which basically gets me to the last. Yes, so this htf over here container go back method, so it will just let me go back. So if I just hit on go back, I'll come to the main page. So this was all about this form. This was all about post requests and how we integrated how we got the input from the form and how we passed the input as a numpy array to the random forest object, which we saved and we unpickled it, and we saw how the results work and how we can transfer the result from the route to the template. So in the next video we'll look at the deployment of this model, which is the most trickiest part. Till then, do practice the code and do look out for Jinja framework or Jinja syntax so that it's easy to understand. Hi, So in the last video we saw how we were able to make all the predictions and how we were able to send the data from the route to the template and display all the results. Now in this video we'll look at the deployment on Microsoft Azure. So if you want to if you already have an Azure account, then it's well and good, you can just log in and do everything. If you don't have an Azure account, then just hit on this create one. Okay, then give some kind of names, just give your email address. Let's say that I give my email address like this. Okay, just give some email address and just give some email address, then give a password, then you create a password for it. You create some password, you'll get some link, you just go on this, I would like to take this, and this, hit on next. And then the important thing in this case is what means you will get some kind of payment. You have to do some kind of payment which will be like a verification for whether that you are a valid user or not. So it will not take, they will just deduct 1 rupee from your account, not more than 1 rupee, because in order to check whether that you are a valid user or not. That's it, nothing more than that. They will not do anything for it until and unless you there will be a free trial period for this Microsoft Azure thing. So if that free trial period expires and you are again and again using these services, that then at that time they will hit a charge on you. So that's not a problem at all. If you use services after your free trial, then they will post some charge on you. If you are not using, then no problem, that's absolutely fine from their side as well. So basically what you need to do is you need to after all this entering code and everything, you'll get an interface where you have to enter your credit card number or debit card number, and then give some kind of 1 rupee or 2 rupee. They will just check whether you are a liable user or not. And note that credit card and debit card, it should be of Visa, MasterCard or American Express or so. Only those credit or debit cards will be accepted, not local bank credit cards and debit cards. So make sure that you fill in all the information correctly, and then after that, after everything is done, the interface of that would look something like this over here. The interface will look something like this. Once you log in, once everything is done, the interface of the Microsoft Azure cloud will look something like this. Okay, Microsoft Azure cloud will look something like this. If I just refresh, you'll get some kind of applications over here, whichever applications you have deployed on, and whichever applications model deployments and whatever you have done, all this kind of things will be looking over here. So now let's get on the now let's start up how we have to do this. So as I said that if you're having a Microsoft account, if you're having this Microsoft account, then Azure account, it's better that you log in and do everything. But if you don't have, I have kept an option over here as well. You can also, I've kept an option over here as well at my GitHub repository. I've kept an option from where you can log in and create your account. So I've hosted the entire code on my GitHub. Even you have to do the same thing. You have to host all the files in the GitHub. Okay, all the files must be hosted in the GitHub. And then what we need to do is, the most important thing is the requirements.txt file. The requirements.txt file is the most important one over here. So over here I didn't make the requirements.txt file, but yes, requirements.txt file is the most important one, which I made it in the GitHub. So it's not a problem over here. So this entire thing will be posted on will be available to you, so it's not a problem. You just follow whatever I'm saying over here. Okay, so this requirement.txt file I need to download. So basically how to download this, so I'll click on raw and then I'll click save as, and then I'll go to projects and requirements.txt. Once this gets downloaded, and that got downloaded. So now basically over here I'm having all this kind of files. So I already deployed this model, so I'll showcase once more. So just a second, I'll just body fat estimator, I'll just download all the code and yes. So once this is done, as usual, I'll be cloning the repository, so it's not no use of that. So what I'll do is I'll open command prompt now. So yes, so now I'll be following these steps. You have to follow these steps and do this. So if you're not having Microsoft Azure CLI, that is command line interface, just hit on this get new link, and then you can get the what we say, Microsoft Azure CLI. So basically the link is over here, Microsoft Azure CLI link. I'll just showcase that link. I'll share the link in the code. Okay, so Microsoft Azure, if you want to install Microsoft Azure CLI, just hit on Microsoft Azure CLI, Microsoft Azure CLI. If you just type this Microsoft Azure CLI, you'll get the first link, and then you download the Microsoft Azure CLI into your system. So yeah, over here you have install for Windows, install for Mac OS, install for Linux, and everything. You whatever operating system is there, you read the documentation and download it. It's not too hard, it's easy. You just have to keep on clicking next. That's it. Then once you have your Python, you have your Microsoft Azure, you have your account, everything is ready. What you need to do is you need to open the command prompt here. So I'll just open the command prompt. So everything what we'll be doing is now from command prompt only. Just now what you need to do is first you need to copy the code and check the Python version. So we see that my Python version is 3.9.1. Now click on this Azure, and then you check the Azure version here. So my Azure CLI is nothing but 2.29. Now once I am done with that, I have to click on Azure login, AZ login. So it will tell me this. So sign into your account. So I'll just sign in into the account, and then I'll be getting you have logged in, and you'll be getting some kind of messages from here that so and so you have logged in with so and so account. So now I need to git clone it. So git clone, and then the repository URL. So in my case the repository URL is this. In your case the repository URL will be different. Now again I'm saying that do upload the code on GitHub. Once you upload the code on GitHub, then only this will work fine. Okay, so upload the code on your GitHub, and then just run this command git clone, and then this will clone the repository into this folder, that is projects folder. So if we just see the directory structure, now I have this body fat estimator which I cloned from GitHub. Now I need to go inside that body fat estimator. So cd, just type in tab body fat estimator. You're inside body fat estimator. Now what you need to do is you need to create a virtual environment where you will be downloading all the files. Okay, so once you click on this, so it will create a virtual environment for you in the body fat estimator. So if you just go over here, you will see this .vnv thing. Okay, so now we need to activate the virtual environment. So if I just type .vnv / scripts and tab, and then / activate tab, and then if I hit enter, now I can see that my virtual environment has got executed or has been activated. Sorry, now I need to install the requirements.txt. So this requirements.txt I downloaded now. So here whatever all the requirements which I used in the web application are there, so I need to download. So these are all my requirements which I need. So all this I will require. So I'll just copy this and I'll simply paste it over here. So if I paste it over here, the requirements will be done. Please note that you should write this -r, that is -r, so that you don't get any kind of pip errors or anything of that. Okay, that is automatically taken care. Now what you need to do is once that requirements.txt file has been downloaded, once the requirements.txt file is downloaded, once the requirements.txt file has been executed successfully, once that is done, and then we will first check whether the web application is working on our local machine first. If it's working perfectly fine, then we will go for deploying it on Azure. We are almost like 70% done with all this. Just two steps are there. One is this Flask run, and one is this That's it. After that, we are all done with the deployment phase as well. It will take some time because there are so many dependencies which I just kept randomly. So yeah, it will take a little bit time to do this. And the disadvantage of Microsoft Azure is that it is very slow, and basically most of the people don't prefer to deploy machine learning models on Microsoft Azure because it is really very slow, very slow. So if I try to run Flask run now, so it should run on my local machine at least. So I'm getting this kind of thing. That means it is working on my local machine, so it will just load. If I copy this URL, and if I paste it over here, I should get the information regarding body fat and everything. Yeah, I think so. It is working perfectly fine. There's no problem in my local machine. It's working absolutely fine. So just go back and then go to this and then exit from this. After you execute, this is the last step which you have to do, that is deploy the model on the Azure. So just syntax is incorrect, so just type in manually. Don't try to copy and paste it here. This is little bit important, so don't try to, I prefer don't copy and paste it, just type it by manually. Okay, SKU B1 minus name. Here you have to give the app name. So I already deployed this, so I'll give some other name over here. Estimator part 2. Okay, I'll give this name. I'll hit enter. Now it will automatically start the deployment phase. Now it will say that web app body estimator part 2 doesn't exist, creating active service plan and so username and this thing, and then creating app service plan on so this thing, and creating web app body estimator part 2, and everything will be working, and this will take a lot of time. So this will take like 5 to 10 minutes. Till then these are all the steps which are there. Once this is done, I'll showcase it in the next video, and I'll showcase what are the advantages and disadvantages of using Microsoft Azure and machine learning also. Okay, till then do follow these steps, do follow this. I have posted into my repository. I have also shared this notebook. I have also shared this readme file, so please look at the commands and execute the commands simultaneously. Okay, till then do practice the commands. Thank you. Hi. So in the last video, I completed the deployment steps. All the steps I have executed step by step, and then as I said that this will take a lot of time. So yeah, it took almost like 10 minutes for deploying it. So that is the disadvantage of this. So basically after deployment, you will get a JSON. You will get this dictionary where you will have all the paths. So what you can do is you can just copy this URL from here and then paste it over here, right? And you can check whether it is working or not. So let's see if it's working fine. I'll just enter some random values, some weights, and if I don't predict, yes, this is working fine. This is working perfectly fine here. So the disadvantage, so I would like to say the disadvantage of Microsoft Azure is it takes a lot of time in deployment. Basically, if you compare to other cloud services like Heroku Cloud or AWS or Google Cloud, they are very quick. Microsoft Azure is little bit slow, not little bit, very much slow in fact. And also sometimes if services are not available, then your entire website will go down and it will show an error like service unavailable and all this kind of things. So in order to deploy machine learning models, Microsoft Azure is not suggested. You can go on with some other cloud platforms like Google Cloud or Heroku. Heroku is like very good because it gives a good service. And the topmost is Amazon AWS, so you never find any errors in there. It's pure. Microsoft Azure is also good, but not that good as compared to this. Microsoft Azure, it's more kindly in use for cloud development and everything, rather than focusing or deploying some models on this. The web app services provided by Microsoft Azure are not that good. Other things may be good, I didn't explore that much on Azure. You can also explore some kind of stuffs on Azure, and make sure that you have some credit card or debit card with you, so that and that too of MasterCard, Visa, or other American Express, some kind of that, so that you can get an Microsoft Azure account and everything. So I hope you enjoyed this deployment series of deploying the full stack web application, data science web application on Microsoft Azure. Thank you.